Hi all. I hope I'm audible to everybody. We'll be starting up in a bit because people are joining in. So we're waiting for some more people to start. Guys, please confirm if I'm audible. Just reply audible. Am I audible? Okay, great. Great. We'll be just waiting for some more people to join in and then we'll be starting off. Okay. All right, guys, I hope people will be joining in the middle of the session. So we'll be starting off. I hope I'm loud and clear to everybody and you are able to see my screen as well. I'm hoping so. So with that, we want to kickstart our session today. And we want to talk about the feature engineering. And this part is pretty much important because once you start with your data science journey, then you need to understand the importance of feature engineering. And a lot of things comprises of this, and none of them is actually completed. So however, it's a lot to talk about feature engineering. I generally take 2-3 days to explain feature engineering, but because here we have a very short duration and short interval of time, I just wanted to give you the glimpses of feature engineering. Okay, so we'll be covering up as much as we can, and we'll talk about, and you're free to ask questions, as many as you can. Okay. This slide and the session is a part of the regular training which we are doing on Saturday, Sundays, on live virtual classes. So I get to meet people and I help them understand what is data science. So one session is going on right now. It's a part of it. Okay. So let's talk about the features. Now, features are the most important part of machine learning, and without feature engineering, you really cannot do anything. If your features are correct and in the right form, then the results which you get in terms of prediction and in terms of output, they are absolutely good. So you need to make sure that the results are good enough to get you the right output. Now, a lot of people do not understand the importance of feature engineering, and that's where they face a lot of trouble. So I would always suggest that before you learn anything, make sure that you learn about feature engineering. Now, there's one famous saying in data science, and I always use that: garbage in will lead to garbage out. And when I say garbage in, which is nothing but the right features and the right importance of the features. Now, with that said, what exactly the features are? Features are nothing but they are also known as attributes, independent variable, predictor, input variable, and these are the values or the numbers which are being given in the data in order to predict certain things. For example, if I have a data, I have multiple columns out there, and these columns are nothing but the features for me. So these features can be in different format. So for example, they can have numbers, you can have characters, you can have letters, you can have different ways to explain multiple things. Now this is the real-time data which I'm showing you right now, and every column is acting as a feature for my machine learning algorithms. Now as per Forbes, 80% of the data scientists actually invest their time in actually creating or making sure that the data is in right format, right, rather than like it could be cleaning or organizing the data, or it could be collecting the data, or it could be finding out the right pattern from the data or refining the data as well, right? So 80% of the time is being given by every data scientist in order to solve it, in order to clean that up. Now, it's one of the most important part of feature engineering. It's is actually it's basically it's a process of transforming the given data into a form which is easier to interpret. Now, this simple line has got lot many things included into it. When I say feature engineering, I mean to say that I want to pick up my data in such a way that it says the same thing but into a different format altogether, which means that I want to clarify, I want to clean that process, I want to clean up this data set into a format wherein it would be easier for me to apply machine learning algorithm, and machine learning will be able to take out inferences or the hidden patterns from the data. Now, what is feature engineering as a definition? Feature engineering is the process of using domain knowledge of the data science to create features that makes machine learning algorithm work. Feature engineering is fundamental to the application of machine learning and is both difficult and expensive. At the moment I say that it's both difficult and expensive, it doesn't mean that it's pretty difficult to apply the logic here. It's always easy to apply your thoughts into the code, but what is the most difficult part is to understand the hidden inferences of it, which means that it's very difficult for someone to interpret what your data is saying. Now, at times you get the features which is very difficult to interpret, and I'll just give you some examples of it. Now, expensive in terms of man hours, expensive in terms of how you want to play with it, expensive in terms of how you want to tackle those feature engineering. That's why it is expensive, because it takes a lot of time and efforts to make sure that it is correct. Now, there is always a need of manual feature engineering, which can be obviated by the automated feature engineering. But in data science, we always look for the manual feature engineering process. Now, this feature engineering has got multiple parts to talk about. Like first thing first is data exploration. Second is what kind of analytics you want to apply on it. The third is feature cleaning. The fourth part is feature engineering, feature selection, embedded methods, and feature preparation. So there is a common part you can see over here, which is called as feature engineering within feature engineering, which I'll talk about and what exactly these parts are. So I'll just talk about each and every part, and I'll give you an idea about what this feature engineering is all about. So first thing first, in feature engineering, which you want to apply is to understand what your data says. Now, what your data say is something which I guess 80% of the people are not able to infer, uh, either they're working on that domain or they are actually using that particular data, but it's very difficult to interpret what data says. And generally I've seen people, they're not able to even infer the graphs. So that's a very common thing. But we need to overcome that situation, and we need to understand what our data is saying. So first thing first, you need to understand what is data, what are different types of data, what are data variables and variables. Now, data is nothing but the collection of facts such as numbers, word, measurements, observation, or even just description of the things. Nowadays, when we talk about the data, we talk about digital data always. And what is that digital data? Nothing but the data which is recorded in digital format. We are not talking about the data which are written in the books. We are not talking about the data which is there on your notebooks or copies or any print format. We're talking about the data which is digitally recorded. It could be a PDF, it could be a website, it could be anything which is available digitally. So data is collection of facts. You can see that there are a number of ways data can be noted, or we can define data in a different way altogether, which is something like this. Data is defined as anything which is organized and has been gathered and organized in meaningful format, wherein it could be processed further. In other words, data are the known facts that can be recorded and have implicit meaning. Now, here I really want to focus on the data which is digitally recorded, not the simple data I'm talking about. However, that is one of the form of the data if it is in printable format, but you can see that the data which is in digital format. Now, the statistical data are the collection of data maintained in organized form. There is a difference between data and the statistical data. If you want to perform any statistical analysis, then data has to be in the organized manner. If it is not, then you have to convert that data into organized manner, and then only you can deal with it. Now, it's very important for you to understand what are the different type of data you can have. So one is variable and constant. I'm sure everybody knows about what is variable and constant. Variable is something which is our item of interest, where we want to apply multiple things and it can have multiple values. A constant has a fixed numerical values throughout our study. It doesn't have the fixed numerical value throughout the world. I'm talking about the throughout the study. For example, if I'm working on a project, if I say a constant value, its constants is nothing but the value throughout my project. It is stable. Statistical data are usually obtained by either counting or measuring of the data. Now, if you talk about the whole data in this world, the data can be transformed. I'm talking about the statistical data, which is recorded in the right format or in measurable format. This data can be divided into two parts. One is qualitative and the second one is quantitative. Now, this qualitative data is nothing but a data which can talk about the qualities, which can talk about something usually expressed in words, not in numbers. You cannot express them in numbers. It's very difficult for you to express them in numbers. And quantitative data is something which can be measured on a numerical scale. Now, if I give you the example of qualitative data, it could be, for example, I'm more honest than you, right? You cannot really judge the honesty on the numerical scale. For example, if I say somebody is doing fairly good, now this fairly good, you cannot rate them on the scale. You can of course pick up that number and convert them to a numerical scale to understand more. However, it, when I say fairly good, you cannot really judge what should be the number of fairly good in terms of numbers. Now, there is something called as quantitative data. Quantitative data is nothing but something which can take a form of word, which has got something can be expressed in numerical scales. For example, I can say that he ran 10 kilometers every day. For example, you can say that his height is 1.96 meters, or you can say somebody's salary is 20,000 or 30,000 for that matter. Anything which can be expressed in number and can be measured on numerical scale is called quantitative data. So I hope that the difference between two things are clear. Qualitative data is something which can talk about the quality. For example, I would say the red color nano and white color nano. So if I have a column where it says the color of the car, if it says red, and the second one is saying white, and the third one is saying black, you cannot really convert them into numbers, and and you cannot measure them on scale, numerical scale. However, you can convert them into something which can give you an indicative meaning of what is red, white, or black for that matter. However, quantitative numbers are pretty much feasible on the numerical scale. It's pretty easy for them to talk about them. Now, if you just bifurcate qualitative data is generally seen in words or letters. Now, many numerical techniques which you have heard of, like standard deviation, variables, mean, median, and taking the variance of it cannot be applied on qualitative data, right? It's very difficult for you to apply those techniques on it because it's not being cannot be measured on numerical scale. And even this qualitative data is of two types. One is dichotomic data and the second one is polynomic data. For example, dichotomic data is something which can have only two possible options. For example, did I reach office on time or not? Will this person is honest or not? Right? You can generally answer them in yes, no. Whether my loan is approved or not, you can always reply them in words: approved, not approved. Right? For example, will I get the credit card or not? Yes or no. Whether the person is male or female. Right? So there are several words which you can use them in, like, you can describe them in words or letters, and then you can always have only two options, for those things. However, we have one more category of qualitative data, which has got more than two options. For example, the colors of the skin, colors of the hair, or body type. Right, there could be n number of body type. Right, what is the color of the car, what is my favorite color, what is my favorite cuisine. Right, so you can have n number of types out there, not only two things. Right, so qualitative data can generally be expressed into two formats. One is dichotomic and the second one is polynomic. Remember, di means two, dichotomic always talks about two possible options, and polynomic always talks about more than two options. So I hope it's very easy to remember. Now, understanding this polynomic and dichotomic is very much important, because on the basis of that, you can define your machine learning algorithm. So it's pretty important for you to understand this. The second one, if you talk about quantitative data is generally expressed in numbers. Either they are the results of counting or measuring. They can be separated into two groups. One is discrete and the second one is continuous. Discrete data, which is the result of counting. Continuous data, if it is the result of measuring. Discrete is number of people in the classroom, number of times you have ice cream, or number of times you got your salary, number of times you've gone to office. Continuous data is nothing but the something which is the output of measurement. Um, for example, it could be what is the height of a person, how many kilos weight you have shredded, or how much water you drink on a daily basis, right? Something which you can measure, right? I hope the two differences are clear with everybody. Can I just quickly get the confirmation from everyone? Are we good with qualitative data and quantitative data? Okay, great. Okay, great. Okay, great. Now, so if you even move down further, right? This is something people generally forget about the data. One is nominal data, ordinal data, interval data, and ratio data. Now, if you just even pick up the quantitative data or qualitative data, they can be further divided into four parts. Now, if you just so this is laying down the foundation of feature engineering. If you understand them, it's pretty easy for you to do the feature engineering, because you know what step to apply, because there is no set rule for solving a certain problem. And then when there is no set rule for solving a problem, only the logic, if you're putting the right logic, you will get the right output. If you don't put the right logic, you might not get the right output. As simple as that. So the four kind of data, and then I'll tell you how to connect basically nominal data, ordinal, interval, ratio data with qualitative and quantitative data. So nominal data is basically which has got discrete unit, and there's no logical order, and there is no particular relationship between them, and yet they are mutually exclusive. For example, um, is it raining today or not raining? Right now, raining or not raining, they have a kind of there is a kind of relationship when I say that they are mutually exclusive, which means that either one of thing will happen, right? Either it will be raining or it will not be raining. However, you cannot see the logical order of it, which means that you cannot give a higher order that if it is raining then it is 1, if it is not raining then it is 0. Or you cannot say like so 1 is higher than 0. I can understand that, but you cannot say that you have more inclination towards, in terms of data, inclination towards if it is raining or not raining. So the things are not in logical order. You cannot, it could be personal perception but not in terms of data. Now, this data is a little bit different. For example, if you talk about ordinal data, you will get much more intuition about the nominal data. Now, this ordinal data has got the categories defined in which the order is implied. Now, the order is what? For example, if we want to say, when I say order is implied, I mean to say that when I say that I've got a rating of A, B, C, D, A being the highest with numbers, or B is the second highest, and C is the average, and D is poor. You can see that here I have a rating. The numbers are expressed, the ratings are expressed in category. It's in qualitative data or categorical data, but they have got some order implied. You cannot say that B is lesser than A, because A is always better than B, right? Now, rating is excellent, good, fair, or poor. This is one of the example where you have an order. However, if it is raining or not raining, you cannot simply apply the order to it. I hope you're getting my point here. So there is something which needs to be applied in terms of order, right? One is better than other, the third one is better than that, and so on and so forth. If the person is male or female, you cannot really apply whether it is good, male is better than female or female is better than male or something like that. You cannot apply that. And nominal data doesn't have this kind of category. Ordinal data has got order applied to it. Even the ordinal data is having mutually exclusive property. Now, when we talk about mutually exclusive property, I mean to say that either your rating can be excellent, good, fair, or poor, either one of them. One of them will appear, but not 100%, right? So this is one of the things which you need to understand. So nominal data is having order implied to it. That's the additional thing which is there as compared to nominal data, right? Ordinal data always have an order implied to it, right? Now, interval data is something which is having even more value. Now, the rating which I'm talking about, excellent and good, fair and poor, can be interval data as well, where the numbers have a distance of constant size. When I say constant size, it means that if you're getting lesser than 40%, you're poor. If you're between 40 to 60, then you are fair. 60 to 80, you're good, and 80 and above, then you are excellent. Now here, the difference between excellent and good, or good and fair and poor, are of constant size, right? I hope you're getting this point, right? And they, in some of the cases, they do not have true zero value. Now, this true zero concept is very, very, very useful. I would just like to emphasize on that. At certain points, when we talk about zero, that zero doesn't have a true zero, which means that in some of the cases, zero doesn't mean actual zero, right? For example, if I say 0 degree temperature, it doesn't mean that temperature does not exist. If I say my sales is 0, then it is actually an absolute zero, a true zero, which means that I am not able to sell anything today, which is my sale is actually 0. However, when I say my height is 0, I do not have a height, or my weight is 0, that I'm basically weightless, which means that if the person doesn't exist. However, when I say temperature is 0, it doesn't mean that temperature does not exist. It means that temperature exists as well. So there are many things which you need to understand in terms of true zero. True zero means that you have the zero means zero, like it doesn't exist. Yeah, correct. Profit can be 0, right? Correct. Similarly, you have ratio data. Now, ratio data goes one step above, and in addition to to this interval data, the numbers are having the constant size, and no, there is a non-arbitrary 0 point, right? Which where it means 0 can be 0, right? So ratio, nominal data, ordinal data, interval data, and ratio data, there's a they have a there are different qualities. Now why we are learning all these stuff? Because there is a logic which we want to understand. At times you need to convert qualitative data into quantitative data. Now why you need to convert qualitative data into quantitative data? Because your tools, there is one logic which you need to understand. Your tools cannot understand qualitative data pretty well. They don't understand what is yes no meaning, what is male female meaning. Yeah, no worries, no worries. So there's no difference between there's no information, there is no information about what is yes no, what is profit or non-profit, or what is good customer or bad customer, or what is the difference between red and black, and so on and so forth. Now this qualitative data is not, it cannot be processed directly into machine learning. So at times we need to convert qualitative data and make it into numerical measures. Numerical measures means that my data will remain qualitative, however I'll be representing them in numerical scale, right? For example, if I say I have something called as red, white and black, I'll call red as 1, white as 2, and black as 3. I'm converting this red, black, and white, or white and black, into 1, 2, 3. However, 1, 2, or 3 has got, you can see that number like 3 is greater than 2, 2 is greater than 1, but they are actually still qualitative. You cannot, you just do not want to take the average of these two things. I hope you're getting this logic, right? You may not want to take, because 1 represents red and 2 represents white, and you still, it is qualitative data. It may look like that it is quantitative, but it is not, right? We're just like changing them into qualitative, right? Now at times your qualitative data can be male female, right? So you can just wanted to represent them by 0 1. If you have excellent, good, fair, and poor, you may want to give them 1 2 3 4 rating, because 1 2 3 4 has got an order implied. So excellent, which is very much similar to excellent, fair, poor, and so on and so forth, right? So the second thing why you want to convert qualitative data into quantitative data is because of the vector thing. Because your machine can deal with only vector data. The data can be, which can be represented in feature space. Feature space is something where data, where computer can pick up the data and show that on the feature space, then only it can pick up the data. Otherwise it has got no meaning at all in machine learning. So you want to convert qualitative data into quantitative data, and you really want to understand what kind of qualitative data you have and how do you want to convert it, right? So I hope everybody is getting this logic. Yeah, are we good, guys? Liaquat, Bhagyalakshmi, Ashish, Suryansh, yeah, right. So Liaquat, you have to convert every column into, every qualitative data into quantitative data, depending upon what kind of data you have, based on the important features. You have to find out which all important features you have, and based on that you want to decide whether the data needs to be converted or not. Yeah, okay. Now what kind of analytics you may want to apply here? The first thing is univariate analysis, right? So univariate analysis is the first step of any analysis, right? So just think about one thing. If I give you only one column of the data, how would you identify, how would you take out inferences from the data? Only one column, there is no other. Like if I have 1000 rows and I have only one column of the data, what analytics you can apply to it, right? That's the basic step of every analytics. You should not be rushing towards machine learning algorithm. You are not supposed to apply machine learning algorithm. I'm sure everybody has tried applying machine learning algorithm at least once. Machine learning algorithm can be applied in 3 lines or 4 lines, right? I hope everybody agrees to that, right? Not more than that. You can just simply pick up 5, 6 lines of code and then you can apply machine learning algorithm, not more than that. A company do not want to pay you for applying, like writing those 5, 6 lines of code, because that can be written down from anywhere. They can just, easily manage that. It's not about writing the machine learning algorithm. It's about how do you infer the data? How do you solve a problem? By inference, taking out the inference. How do you find out the patterns? That's something which makes you unique, right? And generally people don't understand this. They are rushing, they try to learn like 6, 7 machine learning algorithms, and they want to go about it. No, that's not the way to deal with it. Okay, now the first thing is, if I give you one column of the data, how would you apply analysis to it, right? So for what are the things you can do with that? You can always pick up like the graphs to see what my data looks like. So there are a number of graphs like bar plot, count plot, box plot, and distribution plots. Then you can apply some measures of central tendencies, right? And after like picking up the measures of central tendencies, you can always pick up the data and wanted to see what my data says, right? And then you want to apply certain measures of it. Can you represent that data with 1 unit? If I have 1 million rows and my management or my organization asks me to, can you please help me understand this data? You would not be able to explain that 1 million rows there, right? It has got only one column of data. What they actually wanted to hear is either the bar plot or count plot or box plot or distribution plot, just to see how your data is performing. Or maybe if you can throw some figures or numbers about that one column, right, which will make them understand about the whole data, that will be great. That's what they're looking for, right? Because people who are taking decisions, they do not want to understand how much difficulties you have faced while learning data science or machine learning algorithm. So the end results of my analytics is to give them the inferences and give them the idea about what kind of, how do I represent this data. The second kind of analytics you can perform is bivariate analysis. Now, I always want you to think bivariate analysis is as a combination of two univariate analysis, right? So first thing first, you will pick up two different columns. You will do all typical analysis, which is univariate analysis, and then you will try to pick up bivariate analysis and then see what my are there anything which is correlated, is there anything which has got certain relationship with each other. And what you want to do is you wanted to use scatter plot or correlation plot or heat map or a number of things to do this bivariate analysis. Let's see some of the graphs basically. So this is my bar plot, right? And this bar plot is nothing but no liaquat. So this is no this okay, this is correlation is the second step of any exploratory data analysis. You may or may not get the correlation. Nobody can give you the guarantee that there will be a correlation which exists between the two values, right? You always think of, so this is the second step, right? The first step is you wanted to do, if you have two variables, right? You always wanted to do two univariate analysis. I hope you are able to understand this, what I'm trying to say. Yeah, so you always wanted to pick up the univariate analysis first, and then you wanted to go ahead, right? That's why we do summary of the data always. Okay, so now the bar plot, right? The bar plot is something which can help you with the frequency. Now this is the one thing, right, which you need to understand. How would you get a bar plot? The bar plot is nothing but having one variable, and we're talking about the univariate analysis here, right? So univariate analysis is something which will give you an idea, okay, that a actually came 5 times or 3 times for that matter, and b actually came 11 times. Now to plot any graph, you need at least two axes. So one axis, and you have only one data, right? If you have only one data, how would you manage to create a graph? So what you do is on x-axis, you pick up the categorical variable or the label. And on the y-axis, you always wanted to pick up the frequency of the bar plot. So number of times a particular value is appearing can be shown on the bar plot on the y-axis. Okay, so this is something which you wanted to do. So bar plot is the first step of any univariate analysis. You wanted to pick up the univariate analysis, just try and make bar plot and you will have an idea how your data is actually growing. The second thing is count plot, right? Now the count plot gives you the combination of so you wanted to pick up multiple univariate analysis and then you wanted to just do the side by side studies. This is where you actually pick up bivariate analysis as well, and it's a combination of univariate and bivariate. So what do you want to see? How many men and women and child in first class, and then eventually you are doing 3 univariate analyses over here, right? So you have 2 columns where it says men, women, and child, and then you want to have 1 column which says first, and then you have the number of times they are appearing into the data. Now you may not want to apply a correlation over here because it doesn't make sense to apply correlation. However, you can see that in most of the cases that the men are higher in terms of number, and in third standard or third class or third level, you can see that the males, the quantity of males is almost triple of the female and the kids. However, I also noticed that the most of the kids go into third class, right? So it could be it could be any analysis, but it should be comprises of univariate analysis, bivariate analysis, and so on and so forth. Now the box plot, which is absolutely favorite of mine. Your analytics is not complete without box plot. If you don't know how to deal with box plot, trust me, you're missing out a lot of things. Right now, this box plot gives you 5-point summary. Okay, now this 5-point summary is something which you want to pick up and see. Like, so you have several points. You have minimum point, you have q1, you have median, q3, and max. Now the box area is called box of this box plot, and the area which is represented in line is being stated by whisker plot. Now this whisker is help you understand that the upper whisker helps you understand, which has got the max, where is your first 20, like the upper 25% of the data, and the lower whisker tells you where is your lower 25% of the data. However, the most important part of the data is actually lying between Q3 and Q1. So you always wanted to find out where is the 50% of the distribution lying. And this is where the whole game is. You always wanted to find out what is the distribution of the middle 50%, because it makes a lot of sense. Now, this is the first thing you may wanted to apply in univariate analysis. Now, this also defines the outliers in the data, which Excel cannot show, but it's pretty easy if you've used R or Python. It's pretty easy to show the outliers in the data. And then you wanted to pick up like where my outliers are exactly, either in the negative side of the box plot or the positive side of the box plot. So you always wanted to find out the middle 50% of the data, which makes a lot of sense. Now, median specifies the index location. Index location means that it is irrespective of what values you have got in minimum and maximum, the median values, a median is being defined on the index parameter, which means that median exactly divides your data in 2 parts, upper 25% or the lower upper 50% of the data and lower 50% of the data, which is pretty much useful in terms of because this index value is not dependent upon the values you are getting as compared to mean. So they are not affected by outliers in the data. So you always wanted to do multiple box plot analysis. When you get, say, you've got 15 univariate analysis, just try and always compare the multiple univariate analysis out of this data, which is, so you will be creating 15 box plots to understand how my data is actually changing with respect to each other. Notice that box plot can be applied on quantitative data, not on qualitative data, not even on the converted one. So please make sure that you understand this logic. This distribution plot is actually very much helpful in understanding how your data is actually distributed over, like in terms of numbers. So you can see here that most of the values are actually lying between zero point 0.5 to 0 and 0 to zero point 0.5, negatively and positive value. So which gives you an idea about how your data is actually changing with respect to each other. So you can see these values are pretty much helpful in terms of understanding how your data is distributed and where is your target study data. Now here you've got the scatter plot. Now you can see that scatter plot gives you a lot of idea about the various things. Now, if you get to see an idea like this, like how's your lunch and dinner values are, then probably it can give you the first step of bivariate analysis. Now, just think about bivariate analysis as two different columns. Every feature, and the column is nothing but the features, every feature can be picked up as a different univariate analysis. And also once you put that into computers and ask computer to plot the diagram for it, the by default diagram which you will get as a scatter plot, because scatter plot gives you an idea how the things are varying with respect to each other. Now here we need to understand that if I'm saying about the tip is increasing on y-axis and total bill is on the x-axis, and I can see if the total bill is increasing, tip is also increasing. But at times you need to understand the causing, like causation and the direct relationship, right? Causation and correlation, basically whether something is correlated or something is causing other. For example, my cost of living is increasing because the cost of vegetables or grocery is increasing. This is one of the cause which is having an impact. Now correlation is that your salary is increasing and my salary is also increasing. Now if you plot your salary on the graph on x-axis and my salary on the graph, you will get this straight line, or you will get the positive correlation as well. But there is no causation of it. Now the difference between causation is that if one changes, other changes. However, correlation just show the impact of how they are moving with respect to each other. There's no causation. So it's pretty important for you to understand the relationship between causation and correlation, right? I'm sorry about this image. I'm not sure how this actually got into it. uh, okay, maybe it's just something which has happened. Okay, so now this, if it is correlation, then how you can find out? You can always do bivariate analysis, and the first step of statistics which you learn about the correlation thing, how do you find out the correlation, is regression analysis, where you want to fit a straight line between the data and want to understand how your data is moving with respect to each other. And you can always wanted to have a line which can fit the data up to a level where the the you can find out the x and y coefficients. And you can always wanted to pick up the values, which is y is equals to mx plus c, or y is equals to beta 0 plus beta 1 x. You always wanted to find out those correlation which can tell you whether how your values are changing with respect to each other. So this is the first step of bivariate analysis, and from there you actually go into multivariate analysis, where machine learning comes into the picture and can help you with predicting the variables. So when you convert that value from regression, simple regression analysis to multivariate analysis, your equation changes from y is equals to beta 0 plus beta 1 x1 plus beta 2 x2 and beta 3 x3 and so on and so forth, depending upon the number of variables you have. Now, these are the basic plots. Apart from that, there are certain values which are not even correlated with, which do not fall into this category. For example, heat map is something which do not fall into category. So if you have one column which is showing you the numbers and the second column which is showing you the postcode or something, you cannot apply correlation. I hope, Liaquat, you're getting this point, right? You cannot apply correlation to it. So for correlation, there has to be a basic equation that both the values can be continuous only, right? If one value is categorical, another is continuous, you cannot apply correlation to it, and the vice versa. Or even if you have discrete data on both the axes, you cannot apply regression to it. So this is the basic condition for linear regression. Okay. So not always you go for correlation. The heat map is one of the thing which gives you a better visualization about multiple things. Then we're gonna dive into analytics type, right? And then we have a lot many things to cover. So I'm planning to cover this in upcoming week, where we talk about the feature cleaning. What are the ways to do the feature cleaning and feature engineering? I'll just give you the glimpses of it. There are 4 kind of analytics which we want to talk about. And after that we talk about the different values like missing values, outliers, rare values, and high cardinalities. So for example, missing values, why we need to actually treat missing values, what are the ways to treat the missing values. So these are the ways to treat missing values. We need to have example of each missing values, like how we can pick up end of distribution imputation. What are the ways to do the random imputation, arbitrary value imputation? What are the variables? If we have a variable which is having NA, can I change it or can I leave it as it is? So we talked about every type of missing value. Then we talk about different ways to remove the outliers and different other values, right? So we have lot many things to cover up. So we'll be picking up this in upcoming sessions. So like what are the ways to do the feature preparation? So we have a lot many things to talk about this. We are left with approximately 10 minutes. So I just wanted to ask you the questions, like what kind of questions you have, and then we can talk about the rest of the things in upcoming sessions. So let's have questions from you guys. Bhagyalakshmi, are you able to get this logic? These are the ways you can get the feature engineering done. Maybe you want to take a note of it. Yeah. So let's wait for let's take 10 minutes to ask certain questions. So you can ask any question related to the topic today or anything in data science. You're open to ask questions. Preeti, do you have any question? I'm sure you must be having some. Liaquat, Bhagyalakshmi, Suryansh, Mithun. Liaquat, do you have any questions? I'm sure you must be writing. Okay, that's a fair question. How many projects do we need to put up on the resume? Okay, Liaquat, to be honest with you, if you have one project, to be honest with you, okay, if you have one project where you have done enough tasks to explain, like not in terms of picking up the things. Um, yeah, I'm coming to that. Yeah, right. So say so if you go to any, say for example, you've got into one organization where data science work is going on, you will not get the projects every 3 months, right? So just think about the situation, right? You got into a job where you're working on some projects, and then you will not get the projects every 3 months. So someday after 2-3 years you want to change your job, and somebody's asking that did you do like at least 3 projects, then only I'll consider you. That doesn't make sense. So if you have done a project where you know everything, you have actually did it rather than copying pasting it, and you actually put in your efforts there, and you can actually tell the story about your project, that will make a lot of sense. Now the project which you want to do, um, it can have multiple aspects. For example, when we talk about the multiple aspects, for example, if I give you one data and then you are doing exploratory data analysis, how many steps you applied for exploratory data analysis? What are the, now you will not be telling them that, okay, you know what, I have actually treated missing values, you know what, I have actually treated the outliers, and I have done the end of distribution. No, this is not what your interviewer is actually looking for. Unless he asks you to tell, like, how did you do it, you should not be telling all these stuff. You should be telling that, you know, what I have actually got inference from that project is that these many people were actually changing their profile in average, on an average 1.5 years, or the iteration of that company was higher because of certain certain iteration was higher because of certain reason. And that was a very interesting case study which I found out. And on the after finding out that case study, I actually came to know these 10 or 12 logic, why some people actually left their company, and what was why the sales was not higher in some region, and all those kind of stuff. So you should not be telling all these stuff. Now, if I just think about it, if I have a project and I can talk about that project for half an hour, and my interviewer can ask n number of questions from that project, and I'm able to answer all of them, then you are success, right? That the chances of getting that job is much more higher as compared to anybody else. So this is one thing. The second thing is that you might have learned 200 techniques of data science in any of the organization or whatever, like from wherever you have learned. You cannot apply all those 200 techniques to um, you know um, to one project, right? It's not possible. So don't try to showcase that you have learned 200 techniques. Rather than that, try and showcase what problem you have solved. Now, there's very interesting questions which I got, um, that this is so, right. You must have learned about normalization, and you must have learned about outlier treatment, right? Now, guy was asking whether I need to treat outliers first, or I need to normalize first. What is the first step of doing EDA? Right? Can you help me with that? Do you have an answer for it? Preeti, Bhagyalakshmi, Liaquat, Tushar. Tushar is not. I'm sure he might not have got the logic, but Sajid, anyone, like, just think. You're doing EDA. Whether you treat the outliers first or normalize first. How many we have outliers? No, say there are outliers, right? And then I give you the scenario that you need to treat the outliers. Now, to be honest, guys, no, to be honest with you, even if you normalize the data or you don't normalize the data, outlier will remain outlier. So no matter which step you do first. Now the point is that if you understand where is outlier, and what is the definition of outlier, and how does an outlier work, and what is the normalization doing to your data, after normalizing your data, even the outlier will remain outlier. It will not change its position, right? If you understand that the logic behind the both the things, you will not get these kind of questions. So there are n number of things which are going out, right? You just need to understand the logic behind it. So these are the questions, right? So some interviewer may ask you this question as well. But if the moment you say that the outlier first, or you need to normalize the data first, you're gone. So it's a trick question, right? You, even if you normalize the data, the outlier will remain outlier without any trouble. Basically, you're changing the scale. Outlier will remain outlier, right? For the 50% of the distribution, outlier will remain outlier. And that's where you need to understand where my Q3 and Q1 will be after normalizing the data. Even if you normalize it, right, there will be always a problem. Now, what will happen even if after normalizing your outlier is actually outlier? Then what would you do, right? There are n number of things you need to apply. So now you get the data, every kind of data. If you're able to answer the question this way, the interviewer will have an idea that this guy is actually gotten into got into certain things, and actually did the job by his own, rather than just having the bookish knowledge. Now, no, 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 no. Normalization with an example. Sajid, I'll give you a one-liner statement and they will help you understand. Now, I want my data to leave the property of the data, which means that I want to have unitless data. For example, if I have one column which is having the y-axis, which is talking about billions of rupees, and I have x-axis, which is having number of people who are investing into a certain thing, right? I want to leave, I want my data to leave its unit. How would I leave my units of the data? Now this is, everybody talks about, you know, how you can actually do the normalization, but you need to understand the logic behind it. If, how would you leave the unit of the billions of rupees starting from 0 to say 10 billion? Now, how would you do that? You will be dividing that data with min-max kind of thing. And this way your data will be converted into ratio, and ratio don't have units, right? So once you convert that data into ratio, the ratio will not have unit and your data is normalized. Are you getting that point? So the thing is, if you understand the normalization in this prospect, you will definitely clear out the interview. So you need to understand the logic behind the data rather than just picking up the steps and just picking up the machine learning steps. Now at times I tell you what, guys, you will just simply get a data and then your organization will ask you to do something about the data. They will not even tell you that what machine learning to apply and what to figure out. You have to figure out what you can do with that data. You need to give them suggestions what to do with the data, how to deal with it. Now you should have the underlying logic of that. You should spend good amount of time rather than in hurry of applying machine learning. You should not be applying the complete knowledge of it rather than picking up what is important for your data. So the salary doesn't completely depend on age, so we normalize them. It is something like that. No, I'm saying, so for example, in one unit, for example, if I want to see that where people put their most of the money, right, in which, how much money they risk at what age. Okay, now this is something which can increase over a period of time, right? So say somebody has invested say 1 billion rupees in certain stock and his age is only 35, and somebody has put in only 10,000 rupees and his age is 60. So age has got a range of 0 to 100, and the amount he is putting in into the stock is actually ranging from 10,000 to 10 billion. Now one scale is actually very higher in terms of ratio. So what you do is basically you wanted to normalize the data so that age will leave its unit, that the age can be considered from 0 to 1, and the money they are investing can also be converted into 0 to 1 by applying ratio data to it, right? So um, you will be changing the units of it. Well, basically you want the unitless data. Yes, there is a lot of difference in scaling and normalization. Scaling can also be done like I want to scale the billions of rupees into 1 to 10 numbers. So when you apply log to it, you are actually scaling out the data. When you're applying normalization, you are using ratio data to it. Bhagyalakshmi. Right? So log doesn't convert the data into a scale, right? So when you get the convert. So there are n number of ways. We'll talk about the normalization of the data. So I just, if you want to understand this, I have also picked up this logic here where you actually do the transformation. So basically there are multiple ways, which is one way is log transformation. Then you have this normalization and standardization of the data. So generally we do not use this word, but this is actually normalization and standardization of the data. So we have both methods, which is normalization and standardization of the data. So this is normalization of the data, which you're talking about right now. We'll be covering that up as well. Standardization is changing the ratio of the data. That's it. However, the data will not leave its unit, right? So you can always convert the data into the same thing again, right? So we'll talk about that as well. So I hope you're getting this logic, guys. If you don't have any other question, we can call it a day. Okay, Preeti, very good question. Preeti has asked, like, given multiple columns, how would we find out the important features? Preeti, important features can be identified by domain knowledge. Domain knowledge and also by statistical measures. So there are statistical measures which can help you identify. PCA might not give you the exact idea. PCA, yeah, there's one way to find out that, but at times PCA fails because when you talk about there are certain things which we need to understand before you apply PCA even. So PCA will always talk about correlation. It will not talk about the causation and causality, right? Causality and um, sorry, I missed out. Correlation, basically, right? So correlation will always tell you that. So for example, if someday, say in 2020 you got a job of 3 lakh rupees and I got a job of 4 lakh rupees, right, per annum, right? Now in 2021 you got the job of 4 lakh rupees and I got a job of 5 lakh rupees. My salary is increasing with respect to your salary, right? So correlation will show that there is a correlation, right? Correlation. So PCA will always capture that value. However, you know as a domain expert that these two things are not related. However, the correlation exists over there. I hope you're getting this logic. Yep. So you need to understand. So first thing first, when you talk about the columns, there are some statistical measures, but those statistical measure will always tell you correlations. They can always tell you that changing the one column data will actually change the output of other column, or it is correlated. However, they are not the right features to decide the impact of other impact on other features. So that's where the domain knowledge comes into the picture, and you always wanted to pick up domain knowledge to identify whether. I know that if n number of people, if there is a slowdown, then people go for fixed deposit. If the rate of increase, if the FD rates are increasing, then more number of people will be actually coming to my bank to have a fixed deposit. There is a causation and there is a correlation as well, right? But you should be knowing that correlation is actually causation or not. That is being given by your domain knowledge. So before you jump into any data and apply machine learning algorithm, make sure that you understand if and but of every data. If you understand that, it would be easy for you. Now at times, I tell you guys, 90% of the time statistical techniques show you that that there is a correlation, and most of 90% of the time causation and correlation exist simultaneously. But there are 10% scenarios where correlation doesn't exist but causation is there. Okay. And at times, even when you're talking about PCA, your the multicollinearity also plays a very important role, right? And multicollinearity has a problem because people don't understand causation. Then they get stuck with multicollinearity, and then if the multicollinearity exists, then it's pretty difficult for you to identify what is causing what and what is in correlation with what. So you need to make sure that you understand all of them. I hope you're getting this logic, right? PCA is just one way to identify the statistical measure of correlation only, right? All right, guys. One more thing I wanted to add here. There is something called as error component, which is there in the data. When you normalize the data or when you standardize the data, in both the cases, this error also get normalized. So it gets hidden in the data at times. right? So don't think that your error component will get smaller when you standardize or normalize the data. It will remain existent, uh, but it just slightly change itself, but it remain existent in the data. So you need to deal with that as well. So make sure that you apply you have the complete knowledge of the data before you apply anything to it. Make sense? Bhagyalakshmi, Liaquat, Preeti, Sajid, Shelly, Suryansh, Tushar, everybody? Okay, great. So what we're going to do is we're going to see you next week sometime. You will get the notification. Make sure that you join in. And I hope you have enjoyed the session and you got something useful today. We'll keep on continuing our discussion on future preparation and future engineering in upcoming week. I'll take leave of you now. If you have any questions, feel free to contact me or email me. I will definitely be in touch with you. Thank you so much, guys. Take care. Bye-bye.